You read a chapter 3 times. You marked up the paragraphs. But when you close the book and try to remember what you just read, your mind goes completely blank. Reading a text repeatedly makes the words feel familiar. Your brain recognizes the sentences, and you mistake that quick visual recognition for actual understanding. It is an illusion of competence. This is rote learning. It is a completely passive process where you try to force raw text into your short-term memory without ever breaking down what the concepts actually mean. Methodical, we are going to break that habit right now. Pause this video, grab a blank sheet of paper, and get a pen. Real retention happens when you close the source material. If you can build the idea from scratch on a blank page, you know it. If you cannot, you only memorized the shape of the words. This method comes from Richard Feynman. He was a Nobel Prize-winning physicist who noticed a recurring problem in academia. People use complicated vocabulary to hide the fact that they do not actually understand their own research. He developed a simple test. If you cannot explain a topic clearly to a 10-year-old child using everyday words that child would understand, you do not actually know the topic yourself. Over the next 5 minutes, we are going to apply his test. We will take one difficult academic topic and translate it into a simplified Feynman concept sheet. By removing the academic vocabulary, you remove your hiding places. You force your brain to process the raw logic of the idea, making it obvious what you know and what you merely memorized. Step 1. Pick the hardest, most frustrating topic you are currently studying. Write the name of that topic at the top of your blank page. For our session today, we will use photosynthesis as our target concept. Step 2 is the 10-year-old test. From this point forward, you are strictly forbidden from using any of the technical terms from your textbook. Now, write out an explanation of how the process works from start to finish. Use only everyday conversational language. If you need a mental framework, imagine you have to explain how a smartphone app works to your grandparent, or how the postal service operates to a young cousin. You are not reducing the quality of the information. You are extracting the core architectural meaning of the concept so it can stand on its own without the crutch of heavy vocabulary. Now look at what you just wrote. Scan the page for the exact moments where you hesitated, where your sentences trail off, or where you left blank spaces. These points of friction are your actual knowledge gaps. They show you exactly which parts of the logical sequence you never fully learned. This brings us to the jargon buzzer. When we get stuck, our instinct is to write a dense phrase like chlorophyll absorbs photon energy. We do this to mask the fact that we don't know what is actually happening in that step. We need to fix that failure. We translate that step into simple terms. Plants make their own food using sunshine. Step 3. Open your textbook, locate the exact piece of logic you stumbled on, translate it into plain English in your head, and then write that simplified version on your sheet. Pinpointing exactly where your explanation breaks down is highly efficient. Instead of blindly rereading a 50-page chapter, you are now executing highly focused revision on the specific sentences that matter. Now for the final step. At the very bottom of your page, you will write a single real-world anchor analogy. An analogy takes an abstract, difficult scientific mechanism and maps it directly onto a familiar, safe scenario that your brain already understands. For photosynthesis, we can map the biological process of a plant directly onto the process of a chef cooking a meal in a kitchen. We assign roles to each piece of the system. The sunlight acts as the stove providing heat, the leaf is the chef doing the work, and the carbon dioxide serves as the raw ingredients from the pantry. By linking abstract data to a physical scenario, the information becomes permanently anchored in your mind. It is very difficult to forget a chef in a kitchen. Look at your completed sheet. You have reorganized the data from a passive block of text into an active logical sequence. You started with a dense 500-word textbook page. You now have a single, unbreakable summary written entirely in your own voice. To maximize your long-term retention, you can take this written exercise into the physical world. Speak your analogy out loud. You can teach it to a mirror, explain it to a pet, or record a voice note for yourself. We want to see how you applied this. Drop your most creative Feynman analogies in the comments below so the community can learn from them. In our next session, we will look at the chunking method, which will show you how to break down massive textbook chapters into bite-sized, manageable pieces. Understanding isn't about how many technical terms you can recite, but about whether you can explain the logic that connects the facts.